Hi everyone, so for this week, we're just going to be doing some factoring review. So the last time I saw you guys, and I know it's been a while, we had just finished talking about GCF factoring, and then we had just also started talking about diamond factoring. So doing our diamond puzzles, but then just taking it one step further and actually using it to factor, instead of just thinking about it as a puzzle. So for our notes this week, we're just going to re-practice some GCF factoring and some diamond factoring, and that's it. So real quick, GCF factoring. So hopefully you've remembered GCF means greatest common factor. And this means looking at each piece, what we think the biggest thing that we can pull out is. And if we're questioning ourselves, if we can't remember or we can't see just by looking at it what the biggest thing we can pull out is, we can factor each piece using our factor trees and find all the chunks that everything has in common. So first up, we've got 25x to the fourth minus 4x cubed plus 5x. Pause, take a second. What are you thinking each thing is divisible by? What's the biggest thing each constant is divisible by? I would argue that it's 5. But if we didn't remember that, we can factor tree. So 25, what makes up 25? 5 and 5. Those are both prime. Okay. 45. What multiplies by 45? I would say 9 and 5. 5 is prime. 9, 3 and 3. And then 5, well, 5 is already prime number, so 5. Well, at most, everything has a 5. And this is going to dictate that, right? Because this is already prime. So here's a 5, here's a 5, and here's a 5. So the only thing that we can take out, the biggest thing that we can take out is that 5. So we're going to GCF the 5. And then, remember, we go through and figure out how many x's can we take out. There's 4 x's here, 3 here, 1 here. Remember, the smallest dictates how many that we can take out. So because there's only 1 here, that means how many x's can we take out? 1. So I'm going to take out 1x. And then I'm going to set up my parentheses, and we go through and divide. So 25 divided by 5 is 5. We started with 4 x's. We took 1 out, so there's 3 left. Next up, negative 45 divided by 5 is negative 9. We started with 3 x's. We took 1 out. There's 2 left. 5 divided by 5 is 1. We started with an x. We took an x out. So if there's only 1 here, we took that 1 out. Are there any x's left? Nope. So this has been completely factored using GCF. So we did a good bit of this before we left. So hopefully we remember this process. If you'd like, please pause your video here and try GCF factoring this problem. Think about what's the biggest thing that you can think of that divides. If you need to double check yourself using factor trees, double check. All right, so hopefully you guys tried the problem. I'm gonna go through and factor tree and show you guys, hopefully remember how to check ourselves if we don't remember. What multiples make 48? Well, there's lots of things. I'm going to go 6 and 8. I mean, you could have picked lots of things. You guys know that. 6 and 8, neither one's prime. So I'm going to keep going. 6, 2 and 3, both prime. 8 is 2 and 4. 2 is prime. 4 is 2 and 2. Okay, there's lots of things. All right, 60. I'm going to do it like up here so there's room. I'm going to go 6 and 10. 6 is 2 and 3. 10 is 2 and 5, both prime. And then 54. I'm going to go 9 and 6. 9 is 3 and 3. 6 is 2 and 3. All right, so let's go through and see how many things they have in common. So this has 3, 3, 3, 2. So at the very least, they all have at least a 2. So here's a 2, here's a 2, here's a 2. This one doesn't have any more 2s. So we can't pull out any more 2s. Let's think about 3s. This one has at least 1 3. 1 3, 1 3. So I think the biggest thing that we can take out is the 2 and the 3. Remember, 2 times 3 is 6. So our biggest number that we can pull out front is a 6. Now remember, the factoring tree thing, we're just looking for, there's a bunch of 2s and a 3, 3 3s and a 2, 2 2s and a 3 and a 5. We're just looking among all 3 chunks how many pieces do they all have in common? So this is a 3 and a 2, a 3 and a 2, a 3 and a 2. We can't take any more 2s because this one doesn't have any more. We can't take out any more 3s because this one doesn't have any more. This one has a bunch of stuff, but these ones don't, so we can't pull anything bigger. So all 3 chunks have at least a 6 in common, 3 times 2. And if you notice, I kind of chose wisely when I was doing my initial. There's a 6, there's a 6, and there's a 6. So all 3 pieces have a 6. So I'm going to take out a 6, and then we're going to look at the variables. So there's n squared, n, and then no n. Oh no, what does that mean? Well, if this one doesn't have any n's, then can we take any n's out? Nope. So we can't take any n's out. So all we can do is the 6. So 48 divided by 6 is 8. We started with 2 n's. We didn't take any out, so we still have 2 n's. 60 divided by 6 is 10. We started with 1 n. We didn't take any out, so there's still 1 n. And then last up, negative 54 divided by 6 is negative 9. So there's our GCF for this problem. All right, and then, so our last couple days together, we started talking about diamond factoring. So taking a quadratic, and then, so we talked about our diamond is, remember, it's what multiplies to this and adds up to this. So we're going to find 2 numbers that multiply to this number and add up to this number. So multiply is your C value. Add is your B value. And so it goes AX squared plus BX plus C. So your B value is the middle one, and your C value is the last one. So setting up the diamond for this one, we want to multiply to 7 and add up to 8. So hopefully we recognize that 1 times 7 is 7, and 1 plus 7 is 8. And then something that we hadn't practiced a whole lot, we only did it for about a day, is your final answer is you take these and you turn them into chunks. So our variables are, so our factors are r plus 1 and r plus 7. And that's it. So all we're doing is we're basically teaching you guys how to create your own diamond puzzles. And then your last step is writing it as an actual factored quadratic. So let's try this one. I'm going to set up my diamond. So the last one, your C value goes up top. I want to multiply to negative 24 and add up to the middle, negative 2. So think about what multiplies to negative 24 and adds up to negative 2. So take a second. We can try things, right? What multiplies to 24? There's 2 and 12. There is 3 and 8, 6 and 4. Do any of these have a difference of 2? Why, yep, this one, right? So 6 times 4 is 24, but we need negative 2. So which one should be negative? 6 or the 4? 6. And so then your last step is these are your chunks. So then you just, whatever variable you use, this one used n. So your chunks are n minus 6. And your second chunk is n plus 4. Now remember, these chunks are right next to each other because they're multiplying. Because remember, if we distributed back out, we'd get this. So remember, we're unbox multiplying. We're undoing our multiplication. So if we wanted to get back here, we could multiply our chunks back out. All right, so hopefully you guys remember this to some extent. I know it's been a while. So if you'd like, pause your video here and try these two. So set up your diamond factor, set up your diamond puzzle, and try to come up with your 2 chunks. All right. So setting up my diamond puzzle. So the last chunk, this is your C value. This is your B value. If you need to write this down on your paper, you guys can write this down. This is the pattern for our diamond puzzles. So the B value, the middle one, goes on the bottom. The C value, the last one, goes on top. So my C value, I want to multiply to negative 40, and I need to add up to 3. So this is where we start asking ourselves, how do we multiply to 40? Okay, 4 times 10, 2 times 20, what else? 8 times 5. So far, do any of these have a difference of 3? Well, this is 20, this is 6. Oh, 8 and 5 is 3. Sweet. So it's 8 and 5. Now the problem is we need to multiply to negative 40. So one of these needs to be negative. Well, I want to add up to positive 3, so which one should be negative? The 5. So your chunks are n plus 8 and minus 5. Factored. All right, this one. Diamond. You want to multiply to 35 and add up to negative 12. So let's think about what multiplies to make 35. The one that's off the top of my head is 7 times 5. And hopefully we recognize 7 and 5 add up to make negative 12. So I'm going to go with 7 and 5. So 7 times 5 is positive 35. But we need to add up to a negative. So that means both of these need to be negative. So our chunks are x minus 7, x minus 5. All right, if we flip over to the back, I have some more examples for you guys to try. So once again, pause your video here. Try these two. Go for it. All right, so I'm going to set up my diamonds. Multiplies to 16, adds up to negative 10. So let's think about what multiplies to make 16. 4 and 4. Well, 4 and 4 don't make 10, so that's out. 8 and 2. Oh, 8 plus 2 makes 10. Sweet. So 8 and 2. Once again, 8 times 2 is positive 16, but 8 plus 2 doesn't make negative 10. So both of your chunks need to be negative. So our variable is b. b minus 8, b minus 2. Up next, set up your diamond, multiply to negative 28 and add up to 3. So thinking about what makes 28, let's see, we got 2 and 14, but 2 and 14, that's not going to add up to 3 at all. The difference is bigger than 3. What else makes 28? 4 and 7 is the next thing that I see. Is there a difference of 3 between 4 and 7? Heck yeah, there is. So we've got 4 and 7. But the thing is, we need to multiply to a negative. So one of your chunks needs to be negative. We want to add up to a positive 3. So think about for a second which one should be negative. It should be the 4, because 7 minus 4 is 3. So your chunks are a minus 4 and a plus 7. Real quick, just to recap, it doesn't matter where these go. Like, I could have put the 7 over here and the negative 4 over here. I could have switched these. It's multiplication, so it doesn't matter which order you're going. I usually pick haphazardly. I think, yeah. Yep. So yeah, the negative 4 and the 7 can be switched. Even over here, the negative 8 and the negative 2 can be switched. These two chunks could be flipped. Yeah, so it doesn't matter where you write stuff. Just making sure that they multiply to the top, add up to the bottom. And then I have some challenge problems out there for you guys. So these ones are, they have 3 chunks, so they look like our quadratic factoring problems. But the difference is our a value has a number. Oh no. But if you look closely, if you flip back to our GCF problems, we can, this is actually also a quadratic that we should use a diamond puzzle for, but our a value is not 1, and so that makes it not very fun. And what we can do is actually, we can GCF, we can take a number out, and then see if what's left over is something that we can factor. So looking at this, 2, 22, and 20. So the biggest thing that we can divide each piece by, well, it's going to be dictated by the 2, because that's prime, right? So you can divide 2 by 2, 22 is divisible by 2, and 20. Also, I made a typo on this problem. This is negative. Your guys' will be negative. The other problem is if I just take out a 2, so this is not 100% correct yet. I'm going to show you guys. If I just take out the 2, my first chunk here, negative 2 divided by 2 is negative 1 r squared. And we want this value to always be positive 1 so that we can diamond factor. Because if you guys notice the diamond factoring, the number out front, there is no number out front, right? It's technically 1. So the problem is we have negative 1. So what do you guys think we should do? Probably factor out the negative as well. So we don't just want to take out 2. I'm going to take out the negative 2. So negative 2. Negative 2 divided by negative 2 is positive 1. We can't take out any r's because this one doesn't have any. So all we can factor out is negative 2. So negative 2 divided by negative 2 is 1. We started with 2 r's. We didn't take any out, so it's still r squared. Negative 22 divided by negative 2 is positive 11. We started with 1 r. We didn't take any out, so there's an r. And then negative 20 divided by negative 2 is positive 10, no r's. So then what's left over in parentheses here is actually something that we can diamond factor. Woo! So I'm going to write it, it's r squared plus 11r plus 10. So I'm going to set up my diamond puzzle. The negative 2, we're going to ignore that for now so that we can diamond factor, but our final answer will have that negative 2 chilling out front. So just like diamond factoring, we want to multiply to 10, add up to 11. Okay, well, what multiplies to 10, adds up to 11 is 10 and 1. So your chunks are r plus 10, r plus 1. And then all we need to do is, what we've done is we've taken this and broken it down into 2 pieces, but that negative 2 is still chilling out front. So there's this negative 2 chilling there. So this is your final answer. This is completely factored. So these challenge problems are taking both of your factoring skills and putting them together. So step 1, GCF a number. And then step 2 is diamond factor. So if you guys want to pause and try number 2. So first step, GCF, so figure out what's the biggest thing you can divide by, pull that out, and then what's left over, you should be able to diamond factor. So go ahead, pause, try that. All right, so step 1, GCF. Well, we've got a 4, a negative 32, and a 28. So hopefully we can see that it's divisible, all 3 pieces are divisible by 4. But again, if we can't, 3, 2, 2, 32, I'm going to go 8 and 4, 2 and 4, 2, 2, 2, 2. And then 28, I'm going to go 4 and 7. 7's prime, 4 is 2 and 2. So how many of the same chunk does every piece have? There's a 2 here, a 2 here, a 2 here. Okay, what else? There's also another 2 in each one. So there's a 2 here, a 2 here, and a 2 here. This one's done. There's only these 2. This one has a bunch, but this one doesn't. And then, yeah. So 2 times 2 is 4. So the biggest piece we can pull out is a 4. N squared, n, and then, oh no, there's no n's. So we can't take any n buddies out. So we're just going to take out the 4. What's left over? We divide. 4 divided by 4 is 1. N squared, we didn't take any out. N squared. Negative 32 divided by 4, negative 8. Started with an n, didn't take any out, so there's an n. 28 divided by 4, 7. No n's. All right, and then what's left here should diamond factor. So we've got n squared, remember the 1, you don't need it, minus 8n, plus 7. So make your diamond puzzle, what multiplies to 7 and adds up to negative 8. Hopefully we can see that 1 and 7 add up to 8. Oh, sorry. 1 and 7 add up to 8, but we need negative 8. So that means both of these need to be negatives. So your chunks are n minus 1, n minus 7. But remember, we actually started out with factoring something else out first. So this is almost your final answer, but there's something that we need to bring also down, that 4. So this is your completely factored quadratic. All right, guys. So this has been our factoring review. You guys are doing really well with our diamond puzzles the last few weeks of school. We did GCF for probably like 4 or 5 days. We did diamond factoring for a couple of days. So hopefully we remember how to do some of this stuff. Please, please, please ask me questions for our Zoom classroom meeting on Tuesday. That's your opportunity for you guys to ask me questions about this video, as well as any of the homework questions. So your homework questions are on my online website for you guys, WAMAP. So please go try those. And then on our class meeting, ask me questions. I also have my office hours posted on Google Classroom. If you have any questions, you can Zoom me during that time. You can call me or email me, and I'll get back to you guys as soon as I can, and give you guys feedback on this stuff and answer questions you have. Thanks.